So next project up, this is a Hendey 1B universal milling machine. And while it does have a vertical head that you can add onto it, which I unfortunately don't have, that's not what they meant by universal. Universal referred to the fact that this table rotates. So it'll go that way. And coupled with this indexer that can be driven off gears from here, off your feet essentially on the table, you can cut helical gears. So that's pretty cool. So everything needs to be done for this poor girl. She's locked up, so that's not a good start. This is the Hendey tapered spindle with annular bearings. She probably suffers from Hendyitis, which is when this the thrust gets too tight and it pulls it into the taper and it won't move. But generally that happens usually under power when it warms up. So I don't think that that's what's causing this not to move. And it sort of goes a little bit back and forth, and it stops like the bull gear would be engaging back here, but it's not. So that's not what it is. I don't think it's this mechanism, because this bottom turns reasonably well, as far as it can, of course, with the chain on it. And this is the silent chain. We'll see how silent that is. So you get it cleaned up, painted. It needs a complete breakdown, spindle out, find out why it's stuck, and take the table off, clean everything, probably take the knee off. I've left it under here, or I can get to the chain hoist to pull things off. I mean, obviously this needs to be cleaned up. This fortunately will fit in the Hendey lathe, so we'll be able to put that in, put it in a steady rest, spin it up and clean it up there. And then this had this 5 horsepower motor with a GM transmission, manual transmission, of course. And then that was mounted up on this big plate above, and that's how they drove this, which was pretty typical. You know, when line shafts were out of no longer around. This is your lubrication system. You fill that up with oil and position it where you want and just turn it on. It's great. So I've got back in the back there a 3 horsepower 3-phase motor, and then we'll be using a VFD. That's not the one. I need one a little bit bigger. And then this on the front of the motor, and then we'll run it on one of these steps on the cone pulley, and we'll just mount the motor up here, which they did. They have an electric version of this, and we'll try to replicate that casting that's set on top and mounted right on here, on front and back. We'll try to replicate that and put the motor up there, trying to make it look like a casting. Put the motor up there and use the VFD to get our speeds right. And then that way we'll have whatever speed we want. One other thing that I need to determine is this knee. You see how it has these 2 screws on it. One of these models, I know for sure the 2, that actually extends down below, and I guess it had a hole where it was wherever you put the mill. So I need to make sure that one doesn't, because I know I read that someone broke theirs off because it does extend down. So I need to make sure this one doesn't do that. Obviously that'll give it a good bit of workspace when that's all the way down. So I think in order, probably see if this will come off, just because it's in the way and I'm gonna smash my head in it. And then get this chain off, and then go ahead and try to get the spindle out and see if we can figure out what's locking it up. Also, a neat feature of this, they use the Norton gearbox a quick change gearbox that they had. Norton was pulled into Hendey. They bought that and got that patent. I think this is, yeah, so you can see this is before that was all the way in because it's Hendey Norton. I think this, we tried to date this back to 1902 or 18, yeah, I think it was 1902. It was sort of hard to find out exactly. It looks like it's also possible that this guy started out right here in Atlanta, which would be cool. Unfortunately, I tried to verify that, but there's not really any records on that. So anyway, this quick change gearbox goes back to control your feed speeds. So that's really cool. You can see this comes out here, goes down there, and runs over on the feed. And the neat thing about this is this handle disengages. So the feed can run independent of that, and then you just got to ratchet, not ratchet, but you can see how that fits right into there when you want to use it from that side. So it's very cool. All right, well, we'll start breaking it down. Usually, these have a spot for your spanner on one side, and then on the other side, they have like a set screw. That one that we took off on this end had that. This one is missing. Can't tell if it's missing the set screw. Yeah, so I can see a little bit bronze or brass right on the end of this. So I think the screw is out. It didn't want to move, that's for sure. Yeah, this is unfortunate. Same thing. This thing turned a little bit and just locked back up. Wow. Yeah. So I knocked this loose. It was turning fine, and then it felt like something caught in there, and then it just doesn't want to move now at all. Yeah, I don't see anything in there. You can see this one has the correct little piece of, I guess it's brass that protects, so when you put the set screw in, then this way it pushes the piece of brass onto the threads. But I don't see anything wrong with that nut. And I don't see anything wrong with these threads. But wow, that thing was on there. Okay, so next problem is that this has a bolt that goes down onto the spindle, and knowing my luck, it's going to be somewhere down here. I don't see it up here. That has to be undone before you can knock this out. So you may have done all that and not be able to get this thing to turn anyway. One thing I want to do is give this a little tap. Yeah, so if it was Hendyitis, knocking it forward a little bit would have probably gotten it loose. So I don't think that was the issue. Wow. So this gives us a little bit better idea. These were the holes that I was talking about. They're not the same as the ones on my lathe. My lathe had one big one, and it went down in there, and then this screwed down to the, held it on to the spindle. But I remember this actually rotates. It's just a pin in the bull gear that keeps this so that when this turns with the belt, it turns this whole thing. Alternatively, you can pull that pin out, so when this turns, you can see it's turning this back gear. You engage these, and then that's going to turn from there. It goes across and turns here, so it will turn the spindle at a much lower rate. So that's it's got the back gears. That's what that's called. So what I'm trying to do is get to these collars here and on this one, and I'm sort of failing. And I think what I want to do to get there is take off this that connects this, that engages the back gear. So I think I'm gonna go ahead and take that off, and then I can get in there a little bit easier. Okay, so the trick to getting this spindle out is you remove this collar up front, sort of a dust guard that funnels the oil back. You can leave this one alone. Remove the ones that we took off the back, the collar and the gear. And then you're going to knock the spindle this way. And as you do that, this collar has to be, it's going to go that way because it's going to go down the shaft. So turn it, knock it, turn it, knock it, that thing. So the spindle is going to go through comb pulley out the front, and this will eventually, the threads are going that way. Eventually it will work its way off the threads, and then you can push it on out. Okay, so I continued that and really got nowhere. What I did do, and I didn't want to do, is I got this guy out, and you can see I've left these marks on the nose here. But I did get this to turn a little bit, and after 2 times around, it turned reasonably well. I mean, not like it's supposed to, but reasonably well. So I went back, hit it again, and now you can see that it's come out some. So I think that this thing was, I don't know, it just somehow or other fused in there. And my thought was getting it loose, I could then knock it forward. So I'm going to go ahead and run this back again and see if we can knock it out further. Okay, it's out. I can't imagine that you have to hit something that hard to get it out. I was expecting to see some big long score line somewhere where it was, you know, something fell down in there and got stuck. I don't really see anything. I think this part right here looks like maybe it was, I don't know, maybe stuck there. I'll have to find out if that step's supposed to be there. I mean, it looks machined, so I guess it is. Maybe right here. This feels really galled. Really galled right here. And then, yeah, this part's sort of galled a little bit. Not as bad as right here. That's really bad there. I probably need to get this, take that and get that ground out. So it really seemed that once maybe this got past the comb pulley, then it came out. I guess that could have been it. But, I mean, good news is I don't really see anything wrong with it. I mean, other than that one spot. I was expecting something really catastrophic somewhere. But I don't really see that. Obviously, I'm going to need to get a thread file for these. That's not that bad. This came off just as hard as it did before, so hitting that didn't damage it. Really, I think the only downside is this right here. You know, I wasn't making any progress until I got it to turn a couple times. So I think that maybe sort of broke this lock a little bit or something. I don't know. But it's out. I don't see anything really bad. So now we'll just move along. Hopefully the rest of it goes a lot easier. So I'm lifting the table off. This is neat. You can see how the feed is passed up. Since this is a universal table, and it has a universal mill, that means the table has a rotate. So that's how they handled sending the feed up to the x-axis. Very cool. I got most things off, and I'm just now starting to get the final little things so I can get all this dirt off, get it ready to paint. So I went over this with a paint scraper. It scraped up a lot of the grease, got into the loose paint that would come off, and then did the whole thing with the needle scaler. It took about an hour, and I've gone through and wiped it once with lacquer thinner. So obviously that's going to need to be done at least once more, probably twice. One thing I like to do is get everything that's not going to be painted completely done. Polished, cleaned, check things like this, make sure they're functional, all the oil passageways, these little drains. Get this has to come off too. That way, then I'm not trying to clean everything up after I've got a nice coat of paint on it. So, you know, this will get finished cleaning that up. This little grease, oil fitting. These handles, I would love to take these off and polish them, and I may try to do that, but all of these have those tapered pins in them that are hammered over on each side. I think they're tapered. I don't know. I might try cutting one and popping out and see if it's tapered. They're hard to get to too. So we'll see about that. Got all the handles off. I'll go through and sand those that need it, that are really bad, and then get them all polished. And on these, the outside are polished and the inside, the webbing part is painted. So we'll get that done. So we're getting there. All right, we got the table back on. That's great. Well, it slides pretty easy. Now, the one thing we got to find out is I had trouble with the Y coming out this way after I took the table off. So I don't know if something got messed up down here or if it, for some reason, needs the weight of the table to move the Y. So we're going to find that out now. Yeah, so that didn't have anything to do with it. But I've got the Y-axis moving again. And the issue is when I was trying to get the tapered pin out, this guy right here, I moved him all the way over this way, kind of tapped it with a hammer knife so I could get all the way to this side to get that pin out. And what that does, you going this way, locks the Y. So that's why that wouldn't come out. So mystery solved, everything's good. So we've got a bunch of stuff painted. I think pretty much everything is painted. There's one or two little things that I've forgotten about. Forgot about this guy. A couple more things to paint, but it's time to start putting it back together now. The other mystery of why it was so hard to get the spindle out, when I go to put the spindle back in, I'll show you a little bit more, but essentially the spindle is stuck on that bull gear, or face gear. And that's where you're trying to get it out. I remember on my lathe, it's Hendey, but straight spindle. So I was able to take the whole thing out as a unit and put it in a press. So I wish we had a press for this one. So if it was hard getting it out, it's going to be just as hard getting it back in. So that's going to be fun. All these handles, everything was painted red. All that needs to come off and get these things polished up. So we'll polish the outside and paint the webbing black. All right, we're getting a lot closer. So right now I've got the spindle sort of in and the cone pulley on to try to mock up where and how the motors and the pulley and all that's gonna sit. Obviously I don't have the bull gear on. I don't have any of the collars on. I just wanted to get this in to where it was in its position. Find out how far this needed to be out for my longest arbor. So that's in. And then, you know, I hate to do it, but I'm gonna mount that old plate that was on it. I think instead of the transmission that they had on it, I'm gonna do sort of like a jack shaft, a pulley arrangement, and then we'll have a sort of a flat belt pulley that'll go there, and then the motor will hang off the side. I mean, I'll get it up there in a minute. It'll make more sense. But I'm really happy with how it's coming along. I think it's turned out really nice. All right, let me get the motor platform mocked up and I'll sort of show you what I'm thinking. You're getting ready to put the spindle back in, and one of the things I had to do, these were the collars, the threaded collars that were on before, and you know, someone just didn't have the right tool to adjust these. Typical solution for that in those times is to take a punch, put it at an angle and hit it with a hammer, and really what that does is it destroys it. It'll smash the threads in from this side, and then make those so where they're basically ruined. These just would not, I mean, they came off, but it was all my force to be able to get them off, so getting them back on just really didn't work. So I needed to turn new collars, so I turned these, and we'll be putting these back on instead. And I think another thing is that these typically have a set screw, and then a piece of soft material is put down at the bottom, a little slug of copper or soft brass or something of that nature, and then that protects the threads on the spindle or whatever this is attached to, and keeps the set screw from damaging them. And that material is soft and it'll actually conform and sort of form threads itself. So if you look at this on the inside, you would see that piece of material, but it would have thread lines in it. So we'll be putting these on, then we're putting our own little slug of soft copper down in there, and then put the set screws on. So I just thought oh, and I've got, I tried to do a video of making these, but there's just still too much going on for me all around the lathe. There's a lot of stuff and it happens kind of quick. But I do have 2 videos. Here's one. You can see I've already turned it to size, and I set up the internal boring bar here, and I'm taking 50 thou passes and getting a nice finish on this material. And then here I've got it bored to size, and I'm cut 1 thread, and I'm starting to cut the rest. And I cut these to depth. I did make a mate so that on the spindle thread, so I could test this before I took it off the lathe. All right, well, let's get this put in. Okay, we're getting close. It's been a couple hours. That's how close we are. One of the reasons that I redid this nut instead of trying to just live with it or force it on is because the procedure for getting this spindle in is literally to take a piece of wood to protect the spindle nose and hit it with the BFH. I mean, hit it hard. You get it to move a little bit. You take your spanner, you come in and you get maybe a turn. It's so little movement that I put the tape back here to measure if it moved at all. Basically, it is a serious force fit on this spindle onto the face gear, bull gear, back gear, whatever you want to call it. It is a bear, but I think we're getting pretty close. So I didn't want to try to deal with, I already had issues on the spindle with the threads. I cleaned those up with a thread file. I certainly didn't want to have to worry about getting this collar started. I mean, there's very little room in there. It's a real trick to get this up in there together. It's definitely a 2-person job. But I got it in there and I think I'm close. So, and the spindle turns, which is good. All right, so we finally got the motor on. Got the belt on here. I hated to put this plate back on, but I think it looks better. It's certainly better than when I had that old transmission up here. They did a good job on this plate. This plate is hinged. You can sort of get on here a little more. All right, so you can see it's hinged right in here. And so the idea is the weight on the motor is back there. And so that naturally provides a little bit of back. And then you've got this that you can screw in to raise this, which gives you your belt tension here. What I did was put this sort of jack shaft in here. I got a shaft that was original on the front of that transmission, and then I've geared it down. This is 8.5 or 8 1/4, 3 1/4, and that's 3-phase. And the idea is that by the time it comes down through the reduction on the sizes to this pulley here, it's at the middle speed of what it would run normally. So the idea is with the 3-phase, with the VFD, which we have mounted over here. Actually, I just powered this up and it defaults to 50 hertz, so to change that. You can turn this up to, 120 hertz and speed it up, or you can turn it down to 30 hertz, 20 hertz, and slow it down. Obviously a little bit of temporary wiring here, but now we're going to see if this thing will run. I don't have anything in it, so we're not going to make chips, but let's just see if it'll turn over. All right. That's good. Okay. Well, I had a 50-50 chance, and of course it's running backwards. Let's see. Yeah. It doesn't matter, it can run either way, but I'm going to go ahead and switch one of these. This is the idea. It's a weird high frequency noise on there. I think there might be some settings in here I can change. Yeah, it seems to have good torque. These VFDs come with about a 2-second ramp by default. So anything you ask for, it's going to be 2 seconds before it gets to it. I set my others on about a 1/4 second. It gives you a nice run out speed. Doesn't put a lot of strain on it. It seems to be a nice compromise. You can put a braking resistor on it, and it'll stop this thing almost immediately. All right, let's try feed. Alright, it's going that way. Now it's going that way. Cool. And I think, I don't know how you gauge this one. Oh. Yeah, alright, there you go. Nice. And then you can have them both at the same time. So, that's cool. Alright, so I'm going to stop this, switch the leads, get it running in the right direction, and then I've got a little RPM sensor gauge. I can put this on there and we'll find out what the spindle speed is right now. Alright, we got this up at 60, 61. I'm going to try it again. Alright, we got it going this way. It seems really slow. Alright, that's 275. Which I guess is right. $3.93. That's $4.35. That's what I wanted. So that should be the top speed. Just with a normal run. That looks good. So I guess now we put a cutter in it and make some chips. Alright, so let's drop this to 30. Yeah, that's 138. Alright, I'd like to get the ramp speed fixed. Alright, so at 60, it's 266. So I'll have to go and look at the feeds and speeds and all that and see if that's about right. I can always change the pulleys on the back if I need to make a big change, or I just change how I'm running it here. I've got it here to where I can reach it while I'm working. It looks good. I'm really happy with it. So we're ready to make some first chips, and unfortunately, of all the arbors and all the cutters that I got, there's not a combination of the arbors, the cutters, the diameters, the nuts on the end, and the adapters that'll fit. This is really the only thing. All of the arbors are, I got like 4 arbors, but they're all Brown and Sharp 9 taper. I have 2 of the 10 taper with an 1.25" arbor, which is great, but the cutters I have on it are like this big, and I'm not sure that a 3 horsepower motor is going to swing that kind of cutter in anything. So we're going to just try this one, and then I'm going to need to find a 9 to 10 sleeve. And I've looked and I found that on eBay, but they're all for a tang, and obviously that won't work because it needs to be just a sleeve with no back. I do have one converter, but it also is for a tang, and then I do have one 9 with like a collet chuck on the end, which is great, but what I need this for is for cutting grooves, slots, and gears, and I really need the arbor for that. So give this a shot, see how it cuts, and then we'll have to work out the cutter situation. There's a bit of wobble in that. They're like 25 pounds. And let's try the feed. That will be the long way. Alright. Well, let's slow feed. Oh, I don't have the, I got the wrong thing set up. Hold on. Never mind. It's moving. Right. We're there. Almost. They could have done with this with the file. Okay. Alright, let me try and do the depth of cut. That speed is so slow. Alright, let's go. That would be 50, 75. Okay. Start going backwards. Reverse the feed. Not exactly a, what do they call it, the fast reverse? I forget what it's called. Rapid reverse. Not a rapid reverse. Alright. Let's speed in a little bit, and then up at the front, that'll be 100 miles up the sky. Let's try that. Okay. Definitely need to get the feeds figured out. You take it back. I guess you got to turn it off to adjust the speeds, and then we'll try another pass with a little bit faster speed. Alright, so we're in hole 3 now, which is 3 times faster. We'll go. That was weird. Why did it seem like that slowed down? Or? I'm gonna have to go back and look at the video, but it seems to me that that is going fast. It doesn't seem that maybe the belt's slipping. All right, let me look at that video. All right, unfortunately, all the video shows is this belt, and this definitely did slow down, but I can't see if the motor was going slow or not. I can't tell if that was slipping. So I've tightened the belt a little bit, so we'll see if that makes a difference. Alright, so I'm watching the motor now. So it seems to be the same speed. So maybe it was slipping. Alright, so let's try it again. Whoa! That's way too fast. Alright. Reset on that. Glad I was out on the cut. That would have been pretty wide. Alright, so let's try a bigger cut on this. I think that run out's still a really big issue, but we'll see how well it can do. I've touched up on the top here. We'll try 50 thou. It gets faster feed rate. Okay. Obviously, that run out is hurting us on that. It felt like the whole thing was bouncing. But that seems a reasonable cut at a reasonable pace, and a nice finish. All right. So obviously, I got a lot to learn about this machine. I need to get some good cutters. I need to get the arbor, the nut on it. Obviously, that'll be a project to thread that, get the spacers, and get all that together, and really learn what this can do with some good cutters. And we got a couple gears to make, so that'll be next on this. And thanks for watching.